Today we are going to be, simplifying radicals. We have 5 problems, 5 examples to do. Let's begin with the first one. We have the fifth root of x times the square root of x. So we have a square root within the fifth root. So let's solve this right now. Let's rewrite this as the fifth root of x multiplied by x to the 1/2 power. Because when we raise the x to the 1/2 power, we're basically square rooting it. All right? So we can rewrite this whole expression right here as parentheses x times x to the 1/2 power raised to the 1/5 power. Why? Because when we raise this to the 1/5 power, we're basically taking the fifth root. Alright, so we can rewrite it as that. So, and now we can go ahead and basically multiply. We multiply everything inside, so we have the 1/5 power, right? We multiply the 1/5 by, let's just say there's a 1 power right here. We multiply this by that, and we multiply this exponent by this exponent. Whenever you multiply an exponent with an exponent while it's parentheses, you multiply instead of add, alright? So this will give us, when we multiply x by the 1/5 power, this will give us x to the 1/5 power multiplied by x. 1/2 times 1/5 is 1/10 by the 1/10 power. And now we can multiply. This will give us x. When we multiply these exponents, since there's no parentheses, we add them. We add 1/5 by 1/10, which in turn is going to give us 3 to the 10th power. So that's about as much as, well, yeah, that's pretty much it. But we can rewrite this as x to the 3rd power to the 10th root. The 10 will go here, and the third power will stay with the x. We can rewrite this as that. And we see that we can't really simplify this any further than what it already is. So this is going to be our answer. X to the 3/10 power. That's how we do number 1. Let's move on to number 2. The square root of 25 x to the 5th power times q divided by x to the 3rd power times q to the 4th power. So let's go ahead and rewrite this. We're looking for perfect squares. Let's go ahead and rewrite this as 5. Actually, let's go ahead and sorry, I missed a step. Let's go ahead and cancel out the terms, the common terms they have. 5, we have x5q, x3. Sorry, I'm just rewriting this question. I spaced out for a little bit, but we're back. So we see that we have an x and an x here. We have x to the 5th power, and we have x to the 3rd power. This can be written as, well, we can basically, if you know anything about canceling, you know these two will cancel out. And since we have a 5th power right here, it's going to be more than the 3rd power. So the 3rd power and the x is going to disappear because this will cancel this out, right? Same here. The q will get canceled out by the q to the 4th power. So we can rewrite this as 25, the square root of 25, x squared, right? X squared over q3, right? Because this gets canceled out, and so does one of these get canceled out. 3 of these get canceled out, and so does 3 of these get canceled out. So in turn, we have 25x squared over q3, q to the power of 3. Yep, because this one canceled out the one from the top. And this x squared canceled out the one from the bottom. So now we're left with the square root of 25x squared divided by q to the third power. So now we can go ahead and rewrite this as the square root, because we're looking for perfect squares. We can rewrite this as 5x over q, all raised to the second power. Why? Because we can see that we can pretty much get perfect squares out of this. So we have 2 to the 25th, 5 raised to the second power is 25, x raised to the second power is x squared, and q raised to the second power is q to q squared. But we're missing something, right? We're missing the extra power, because remember, I'm gonna write right here, q to the second power times q is going to give us q to the third. We're missing that q, so that is when we can multiply here 1 over q. Now this will give us that. So now we're complete. So what can we do here is this is obviously a perfect square, so we can take that right out of the square root. So this will give us 5x over q times the square root of 1 over q. Alright, just like that. And yeah, basically we can rationalize this by rationalizing the denominator. We can do that by rewriting it as the square root of 1 over the square root of q. So we're rewriting this as that. Alright, so now after that we can rationalize the denominator by multiplying the square root of q over the square root of q, and that is going to give us the square root 1. Well, I forgot to mention this, but the root, any root of 1 is going to equal 1. So the square root of 1 is going to just equal 1. So just ignore this. So it's just 1 over the square root of q times the square root of q over the square root of q. 1 times the square root of q is going to give us the square root of q. And square root of q times the square root of q is just going to give us q. So now we're left with the square root of q over q. So now we can go ahead and multiply this piece along with this piece to complete it. Let's move right here. So we have 5x over q times the square root of q over q. We multiply and we get 5x times the square root of q over q times q is going to give us q to the second power. Q to the second power. That looks like it's going to be the answer for number 2. Just like that. Check your work. That is how you do number 2. 5x to the square root of q over the q divided by q squared. Yeah, that's about as much as we can factor this. Simplify it. Yeah, I don't really see any way we can simplify it, so that's going to be our answer for number 2. Let's go on to number 3. The square root of 16x y to the 5th power multiplied by the 6th root of x raised to the 5th power times y raised to the 2nd power. Right off the bat, we can see that the square root of 16 basically makes a perfect square. So we can go ahead and take that out. It's going to be 4. And let's just separate this just to make it easier on us. Square root of x times the square root of y to the 5th power. Why is there a 4? Because like I said, the 16 makes a perfect square. 4 times 4 is 16, so we already have our perfect square right here. So let's just work with these pieces for a bit before we move on to the rest of the problem. So we have the square root of x. It seems like we're just going to have to leave it like that because this can't really simplify into anything else. But we can do something about the square root of y to the fifth power. This equals the square root of y squared times the square root of y squared times the square root of y. So if we multiply the square root of y squared plus the square root of y squared, it's going to give us the square root of y to the fourth power times the square root of y is going to give us the square root of y to the fifth power. So this gives us that. And these are perfect squares, right? So we have y, the square root of y. So this is going to give us y squared times the square root of y. So let's move on here. Now we have 4y squared times the square root of y, the square root of y, and the square root of x that we couldn't really simplify any further, so x and y. So 4 times the square root of y squared, 4 times y squared times the square root of x and y. So now we can go ahead and pretty much work with this one. Now we have the sixth root of x to the fifth power times y to the second power. So now we can go ahead and do our multiply. So we can rewrite, let's just go ahead and do it here. We can rewrite the square root of y as x times y to the 1/2 power, right? Because this is pretty much the same thing as that. Cool. And we can rewrite this one, the sixth root of x5 to the times y to the second power, as times parentheses x to the fifth power times y to the second power to raise to the 1/6 power. Good, because this is going to equal that. Cool. Now we have x times y all raised to the 1/2 power times x to the fifth power times y to the second power all raised to the 1/6 power. So let's try and turn this into this to the 6th power. The way we do that is we take the least common multiple of 6. So we have this exponent 1/2. We want the denominator to be equal to 6, right? How do we do that? We multiply a 3 over 3 because that's the least common multiple of 6. That's going to give us 2 times 3 is 6. 1 times 3 is 3. So now we replace this this exponent with the one we have here. So this becomes x to the y, x times y, sorry about that, x times y to the 3/6 power multiplied by x to the fifth power times y to the second power times 1/6 power. Alright, so now we have that. And now we can go ahead and basically translate them back into the 6th root. So this is going to turn into, let's see for a second, this is going to turn into oops, we don't really have space there. Well, let's do it here. The 6th power of x to the 3rd power times y to the 3rd power. Right? We have x to the 3rd power times y to the 3rd power. Why? Because this one will go here, right? It's going to go on the outside. This 6 will go on the outside, and that will leave us with the 3rd power. So that means we'll multiply everything inside by the 3rd power. So that is going to equal to x to the 3rd power times y to the 3rd power. Obviously, we have the 6th root here, and now we can bring this one down here. So again, the 6th root of basically x to the 5th power times y to the 2nd power. So now, since we have the 6th root here and the 6th root there, now we can multiply both of them together. And this will give us, let's write it here. This will give us the sixth root of x to the x cubed times x to the fifth power. That will give us x to the eighth. X to the eighth, because remember, you add the exponents in this case. Y to the third power times y to the second is going to give us y to the fifth power. Again, check your work, make sure everything is good. So we have, x to the eighth times y to the fifth power. All right, we're not done yet. And now we can go ahead and break these up. So we have 6 to the x eighth power, and we also have the sixth root of y to the fifth power. We can't really simplify this pretty much any further. That's just about as how it's gonna stay. So this is how it's gonna stay. And right here we can basically rewrite this as x to the sixth power, the sixth root of x to the sixth power, times the sixth root of x to the second power. Why? Because x to the sixth times x to the second power is going to give us x to the eighth power. So multiply this together, you'll get that. So we can rewrite this as this. This is even, so when it's even, this 6 and this 6, this is going to equal the absolute value of whatever's inside. In this case, it's just going to be x. X times the sixth root of x to the second power, and we can't forget about this one, the sixth root of y to the fifth power. So this is going to pretty much equal to x times the sixth root of x squared y to the fifth power. So the sixth root of x squared y to the fifth power, cool, but we can't forget about our perfect squares that we left up here. Remember these? I hope you do, because this is important as well. These are the perfect squares that we got out from the beginning. I hope you remember it. If not, just rewind the video and rewind this problem and just watch it so you know where we got this from. This, we're gonna bring this, we're gonna bring it all the way here and add it, well, not add it, but multiply it to this. So we have 4y squared, right? 4y squared. 4y squared times x times the sixth root of x squared plus y to the fifth power. I'm going to rewrite it again so you can see it better, but this is 4, well, that looks worse, 4y squared times x times the sixth root of x to the second power times y to the fifth power. All right, 4y squared plus times x times 6 times the sixth root of x squared times y to the fifth power. Yep, that's going to be your answer. Going to be your answer for number 3. There's my work. All right, now let's go on to number 4. We have, the fifth root of L to the 8th power divided by the fifth root of L to the 3rd power. We can rewrite this as using pretty much the properties of the nth root. I made a video on it. We can rewrite this as the fifth root of L to the 8th divided by L to the 3rd power. We can go ahead and cancel out what they have in common. In this case, it's L to the 8 and L to the 3. This is going to cancel into this, which will leave us with L to the 5th power. Obviously, we can't forget the 5th root, because this will go into that. They'll cancel each other out. When we divide exponents, we subtract them. 8 minus 3 is 5. So we have L to the 5th power after we finish canceling. Obviously, we can't forget the 5th power, and we have that. Since this is odd and this is odd and they both match up, this is just going to equal L, right? And we can't really simplify L any further than that, so that's how you do number 4. Let's move on to number 5, the last one. We have God damn it, focus. Sorry. Focus. Sorry about that. The fourth root of x. Yeah, I'm not gonna restart this video. I'm already almost done anyways. So we have the fourth root of x to the 3rd power times the 6th root of x to the 2nd power. Alright, so we can rewrite this one as, let's just rewrite it here, x to the 3/4 power. And that's how we rewrite this one. This will equal that. Times x to the 2/6 power. We can multiply these two together to get x. You add the exponents to get 13/12. So that's how we do that one. Well, that's how we multiply. And we can rewrite this as the 12th root of x raised to the 13th power. It looks like we can simplify this a little bit more. This is going to be equal to the 12th root of x to the 12th power times the 12th root of x. Because this times this will give us that. X to the 12th times another x is going to give us x to the 13th. And we have the 12th root right here. So yeah, this confirms that this, when you multiply these together, you will get that. So this is even, so it's going, this and this pretty much match. So, and it's even, so it's going to be the absolute value of x, which is just going to be x times, we can't simplify this any further, so it's going to be the 12th root of x. So it's going to be x times the 12th root of x. That is how you do number 5, and this is the work for all of the problems, like that. And with that, we are done with the 5 examples of simplifying radicals.